Today, I just want to do the practice test debrief. I'll do each of the problems, show you what I was thinking when each of the problem, my intent for each of the problems. And then, yeah, that's all we have planned for today. So in the first problem, in 1A, in problem 1, we're writing the equation of a line. There's three different in problem 1, we're writing the equation for a plane. There's three different planes. I just want the equation in whatever form. Since we're writing and not typing it, any form that occurs to you to give me first is valid. Standard form, function form, point, slope, slope form, whichever. In the first one, we have a point 0, 0, 7. So that's a point that we want to use. And then we just look at the change in z divided by the change in x and the change in z divided by change in y. So in 1A, we have a point 0, 0, 7. And we've got a change in z with respect to x. So if we look at the table of values, when x increases by 5, z is decreasing by 4. 7 minus 4 is 3. 0 plus 5 is 5. So the change in z with respect to x is negative 4/5. If we look at the change in z with respect to y, we see that when y increases by 2, z increases by 4. So 4 divided by 2 is 2. Change in z divided with respect to y is plus 4 over 2, or just 2. With this information, with a change in dz dx and a dz dy and a z naught of 7, that's how we'll build the plane. It's most convenient to use the function notation. So z is equal to z naught plus change in z with respect to x times x plus the change in z with respect to y times y. This was our most popular answer. It's the first one that you come across. My intention for the second problem was to, since I gave you a point and a normal vector, is to remember that the coefficients in standard form give you the coordinates or the components of the normal vector. If you have the components of the normal vector, you can just put them into the standard form. So you have a point, -2, 1, 5, and a normal vector of 3, 4, -1. The coefficients in the standard form are the components of the normal vector. So in the x direction, I've got a 3, but x starts at -2. The y component is 4, and y starts at 1, and the z component is -1, and z starts at 5. This is how we build the equation in standard form. We have the coefficient, the components of the normal vector are the coefficients of x, y, and z, and we just shift x, y, and z to a point that we have available. 3, -4, 1. 3, -4, and 1. Plus 1. Thank you. So at this point, if we multiply all this out, we can get the standard form with none of this shifting going on. So we have 3x minus 4y plus z. 3 times 2 is a 6. -4 times -1 is a 4. And 1 times -5 is -5. So it's 10 minus 5. On this side, it's a 5. On the other side, it's a -5. This was our most popular answer. No one left it in that original form. That's okay. Y'all felt like that. So. I don't like just writing this. In 1C, I gave you 3 points on the plane. We can take the 3 points on the plane, get 2 vectors in the plane, and then we can get a normal vector by doing the cross product. There are other things that we could do. This is most direct because all we need is a point and a normal vector to build an equation. And that way, the only calculation we have to do is the cross product. There are other things that we could have done to build the one equation for this. We can describe things parametrically because we know it's going to be linear. The easiest thing to do for this, since I want the one equation for the plane, not parametric equations for the plane, is to build 2 vectors. So we have the 3 points, P, Q, and R. So I took the vector, I found the vector PQ, and then I found the vector PR. And then I just calculated my normal vector to be PQ cross PR. So in the calculation, PQ is going to be, I ended at Q, so I do 3 minus, do the Q component minus coordinates, Q coordinate minus the P coordinate. So 3 minus 1 is 2. -1 minus 0 is -1. And 6 minus 2 is 4. And then the PR component, I just do 5 minus 1 is 4. 2 minus 0 is 2. 4 minus 2 is 2. We just subtract components to find the components. Subtract coordinates, find the components. Keep speeding up. I don't know if this is a more coffee problem or a less coffee problem, but I know what solution I'm going to apply. It's always the answer. Now I'm just going to find the cross product of these 2 vectors. So across the top is ijk. In the middle, I'm going to do 2, -1, 4. And down across the bottom, I'm going to do 4, 2, and 2. The I component is going to be the minor of j, so -2 minus 8 is -10. The j component is going to be 2 times 2 is 4 minus 16, which is -12. But we alternate signs in the cofactor expansion, and then the k component is 2 times 2 minus -1 times 4. So 4 plus 4, 8. This is what we could use for the normal vector. This is only halfway done. This gives us the normal vector. This is not the equation for the plane. So it's 2 points to get the normal vector, the correct normal vector, in either direction. So 10, -12, -8 is also valid if you just switch the order or if you just do 2 different vectors, like QP and QR or RP and RQ. I can't do more perfectly. Now we want to build this just the same way we did in the previous one. We can choose any one of the 3 points. The other thing that we want to note is that P, Q, and R are points, not vectors. We got to subtract to get some motion to get some vectors. What's that? 3 from what 3? This one here? Well, that's where we're headed. So now that we've got the normal vector, I cut it in half on this one. But now that we've got the normal vector, I can make these the coefficients in the standard form with any one of the points. I'm going to pick the 1, 0, 1, 0, 2 because that has a 0 in it. So then we take the normal vector and put it in. So I get a -10 times x minus 1 plus 12 times y minus 0 plus 8 times z minus 2. There's the standard form using the point 102. If we multiply this out, actually, if we divide by 2, I divided by 2. If we multiply this out, we can get the standard form with the constant on the other side. So this is going to be a 10. This is going to be a 0. This is going to be a negative 16. So 10 minus 16 is a negative 6 on this side, positive 6 on the other side. So we could go negative 10x plus 12y plus 8z is equal to 6. So that's where I got the 3. I then divided by 2 because I noticed my equation was twice as big as it needed to be. Some of you solved this for z, which is perfectly fine. Some of you got at the change in x divided by change in y in a different way, which is also perfectly fine. This is what I expected you to do. Yeah. Four points per part, 12 points total for the first page. In 2A, what you wanted to notice is that we're looking at we can find the normal vectors for these planes very easily. And the thing that we need to realize is that the angles between the normal vectors will be the angles between the planes, because it's just an angle in between. If I take that and rotate it 90 degrees, that angle won't change. Angle between the normal vectors is equal to the angle between the planes. So I just need to find the angle between the normal vectors. So we would find our normal vectors. Of -5, 6, 4. And this normal vector is 1, -2, 3. And then we're going to combine this with the fact that n1 dot n2 is equal to the magnitude of n1 times the magnitude of n2 times the cosine of the angle between them. 4 things in this equation. We can find 3 of them. So that'll tell us the 4. The magnitude of n1 is going to be the square root of -5 squared plus 6 squared plus 4 squared square root of 77. And the magnitude of n2 will be the square root of 1 squared plus -2 squared plus 3 squared, 14. And n1 dot n2 will be the sum of the products of the corresponding components. So -5 times 1 plus 6 times -2 plus 4 times 3. So -5 plus -12 plus 12, -5. Dot product is negative. So we know we're going to be getting an angle that is obtuse. So theta is cosine inverse of -5 over root 77 times root 14. I requested the answer in to 3 significant figures. So 3 significant figures just means write 3 digits. So it's like 9, 8, 7, 6. The 6 moves the 7 up to an 8, and so we write 9, 8.8. I did not take off if you wrote 3 decimal places, the nearest 1,000. I just wanted to find out. That was just me asking about significant figures. So I'm like, hey, have you encountered significant figures before? And some of you are like, oh, didn't read that part. Some of you are like, oh, didn't read that part, still wrote 98.8 through sheer luck. But you don't say that part out loud. I'm like, oh, what's the answer? I'm like, 98.8. Are you guessing? Am I right? Yes. Then I'm not guessing. Do you think you get most advantage? Exactly. I try to assume that you know what you're doing until I have proof that you don't. On the other side of that, I work on the assumption that you're just incorrect and not lying to me. Oh, you made a mistake. Does that make sense? There's a difference, right? Because if you're just incorrect, I mean, that's like, if you're trying to lie to me, that's kind of offensive. Some of you got away with it. Just want you to know, I know. I always know. In 3A, we are asked to show that A cross B is orthogonal to A, or perpendicular to A. I introduced the cross product. The point of this cross product is to find a vector that is perpendicular to both of the vectors in the product, both of the factor vectors. That's how I sold you on the cross product. In this case, I'm asking you to prove that that is the case. And the best way to do that is to just show that A dot, just do A dot A cross B is equal to 0. This is a bookkeeping exercise. That's what it looks like. I highlighted the things that match up, but I just calculated the cross product of A and B using the components, and then I did the dot product of A with that, and then it makes those 6 products all opposite pair, all have opposites. Cross and dot. The dot product of vectors is equal to 0, and the angle between the vectors is 90, and therefore they are orthogonal or perpendicular. Any questions? How's everybody okay? It's funny because looking at that problem, I could see that. I only saw it, I didn't see it in time. I saw it frozen in time at the end of the class, but I could see where you started to write that, wanted to bail on it. It's like, well, no, it can't be this, because this is like a lot of bookkeeping. You're like, oh, no, that's terrible. Seems like this is a terrible idea. And you were about to back out of it. It's like, oh, I better just keep going because it's the only idea I have. Right. And then so you continue on, and then you get the test back today. It's like, oh, holy shit, that's what you wanted. I'm like, oh, yeah, that's all I wanted. And I go, well, but it's like a proof, right? Sometimes that's what a proof is. This is what you call a follow your nose proof. You just have to start doing some calculations. Sometimes a proof, all that's required in a proof is that you do some calculations, then bark out the answer. How do we do calculations to show that things are orthogonal? Show that their dot product is equal to 0. How do we find the dot product? by sum of the products of the corresponding components. One of the vectors is a cross product. How do we find that? First, we're like all mutter under our breath, God damn it, Leach, do we really have to do the cross product? And like psychically, I'm like, oh yeah. And I go, well, fuck. And then you do the cross product, dot product with A, comes out to 0, and you're like, oh, victory. And I think some of you had, these didn't cancel out, but I'm like, oh, it looks like it. And then so I started checking out like down here to make sure you had all the pairs or all the triples that you needed. But then I was like, oh, it looks fine. Who's going to guess that? Who is going to guess that and get it wrong? You know what I mean? That's called the untouchable rule. I don't know if you've seen the movie Untouchables. At one point, Sean Connery walks up to Kevin Costner, finds out that Kevin Costner is carrying a gun and is not dressed as a cop. And so, hey, why are you carrying a gun, Kevin Costner? And Kevin Costner says, I'm a treasury agent. And Sean Connery was like, all right. And he starts walking on. And Kevin Costner's like, oh, dude, you're not going to ask for identification? And he says, if you're going to claim to be something, that's not what you're going to claim to be. So same kind of thing. You're in the calculation. Once I see you start trying to do this, I'm like, oh, I just look for the equal 0 at the end. I'm like, oh, yeah, they got this. Some of you got away with it.
So when you do this, oh wait, no, it's divided.
Yeah. Because A cross B has those 3 components that are all these differences. And then A dot that is just A1 times this first one, A2, and then A3. And it makes stuff cancel out. How's everybody okay? You're just happy I didn't say perpendicular to A and B. Then you have to do all these with B's and A's switched. How's everybody okay? The Canvas portion of the practice test has not showed up on Canvas yet because it takes time to input things. I'll probably not be having this last one on there because you don't want to type that. You don't want to type that. Because I'll be like, oh no, those all have to be subscripts. So you have to like highlight each one and hit subscript. Because if you do A, then _1, it won't just automatically make it a subscript. Any questions, comments, new thoughts? Not anymore. Yeah. The online one will be due the week following when it shows up. It probably won't show up until Monday. It's Friday. I'm probably not going to get it posted today. Yes. They do not. I'm going to try to give you multiple versions. These are definitely going to be there, right? But I'm going to try to give you multiple versions because I want, so I'll solve them for Z. Remember that if you're going to use coefficients, that's actually a great point, a great question. If you're going to put things in standard form, or if you're going to put things in single line syntax, is Z equals 7 minus 4/5. You need parentheses before you multiply by the X. You technically don't. There's an argument to be made that you technically don't, but I am demanding it. This is the extra thing that you have to do for me because I'm not going to let you go out into the world and drop unclear communication on people. I don't want you to say 4/5x and then be mad when someone reads that as 4 with the 4/5x with the x in the denominator. Does that make sense? This way, no one gets it wrong. But otherwise, if you just leave off the parentheses, otherwise you'll just have to be like the guy that's like, oh, actually, the order of operations has division and multiplication on it. You don't want to be that guy. Make the communication clear in the first place, which is clearly something that I didn't do. So that's why we have the online course. Take revenge. It puts a floor on the problems. Any questions? Yes. What's that? Yeah, that would get the same point across. I usually don't put this one. So if you put that and it marks it wrong, you can go back and just kind of like change it around, or you could send me an email. It's like, and just have that with the 4x minus 5, and I'll get the message. That would be the funny way to do it. Just send me that in an email. No other explanations. Like, oh, excuse me, I put this and it was marked wrong. The funny way to do it would just be to send me that. Actually, just in the subject line and leave the body of the email empty. And I'll be like, oh, all right, and then I'll go in and fix it. It's not even fixing things. I would go in and add it. +1 for snow. So I'll try to put some variations on. If you're convinced that your variation is right, just send me an email. It's like, oh, dude, you left off my variation and I want that representation. Then I'll try to accommodate that. All right, that's going to do it for today. That's going to do it for this week. I will see you all on Monday. Everybody have a good weekend and thanks for playing.